Next question on the test asked me to find the probability that a proportion is between two values. In order to find this, I'm going to have to find the z-scores for each. The z-score formula that I'm going to use is z equals p hat minus p over the root of p times 1 minus p over n. So for 0.26, the z-score is going to be 0.26 minus 0.3 over the root of 0.3, 1 minus 0.3 over 90. And then I'm going to find the z-score for 0.37 the same way. 0.37 minus 0.3 over the root of 0.3, 1 minus 0.3 over 90. So my first step is calculating these z-scores. Then I'm going to need to use the table to find p-values, and then I'm going to need to subtract to find the area in between. My first z-score parentheses, 0.26 minus 0.3, end parentheses divided by new parentheses, the root of parentheses, 0.3, end parentheses, new parentheses, 1 minus 0.3, end parentheses divided by 90, end parentheses. When I put all of that in, I get negative 0.828, which I'm going to call negative 0.83. I then do the same, except now I change my 0.26 to 0.37. When I do that, I get a z-score of 1.449, which I'm going to call 1.45. So here it's negative 0.83, here it's 1.45. I now need to go to my table and look each of these up. When I look up negative 0.83 on the negative side, I go over and that points me to a p-value of 0.2033. P equals 0.2033. On the positive side, when I look up 1.45, 1.4, go over to the 5, I get a p-value of 0.9265. P equals 0.9265. So I now have two p-values. For a between question, I take the larger one, 0.9265, minus the smaller one, 0.2033. When I put that into my calculator, 0.9265 minus 0.2033, that's how I get the correct final answer of 0.7232. For question 16, it asked me to find a confidence interval for the mean. In order to do that, I need to know what the z alpha over 2 is. For 95% confidence, that's 1.96. Remember, there's only 3 key ones to remember. For 90%, it's 1.645. For 95%, it's 1.96. For 99%, it's 2.575. I highly recommend you have your notes out while you're taking this final and that you have that information in your notes. After I get that z alpha over 2, I also need n, which is given, and I also need s. We've seen this question a number of times. I don't have ones to choose from that give you s. They give you variance and make you find s. Please don't make this mistake on the test. You only get one try at it, but you need to remember when you see s squared, that's not what goes into the formula. What goes in is s. So you really want to take the square root of this. If you take the square root of 3.72, I get the root of 3.72 to be 1.92873. So I'm going to call that 1.93. I now have everything I need to find my margin of error. My margin of error calculation, which I'm going to call it MOE, is the z alpha over 2, 1.96, times the standard deviation of the sample, 1.93, over the root of n, in this case the root of 64. When I put that into my calculator, 1.96 parentheses 1.93 divided by the root of 64, I get an answer of 0.47285. I want to look back and see what the decimal places they wanted. So it says 2 decimal places. For 2 decimal places, I'm just going to go to 0.47. Now that I know how much to move, I need to move off of the given sample mean. Notice we haven't used x bar 13.6 anywhere in the formula yet. The only place we use it is to add and subtract. So we're going to take that 13.6, that's our mean, subtract 0.47 for the low end. We're going to take that 13.6 and add 0.47 for the high end. That means that when I do my low end, 13.6 minus 0.47, it gives me 13.13. When I do it for the high end, 13.6 plus 0.47, it gives me 14.07. So the first two answers to the question, the lower bound should be 13.13, the upper bound should be 14.07. It does ask me to interpret the interval. It gives me 5 multiple choice answers here. What I want is something that says we are 95% confident that we have captured the true population mean. The other ways that it could say it is in repeated intervals constructed like this. 95% of them would contain the true population mean. So really that confidence level tells us if we kept doing this, what percent of the time would we capture the mean versus our error, which in this case would be 5% of the time that the true mean wouldn't be captured within our interval. So I'm going to interpret this interval as the interval will contain the true population mean (95% of the time). The wording on this may be different. Again, you might have it phrased as in repeated confidence intervals, 95% of the intervals created using the sampling method will contain the true population mean. When we get to question 17, this is the beginning of hypothesis testing, where all we're asking is to set up a null and alternative hypothesis. First thing we need to get right is which symbol we're going to use. In this case, because we're trying to design a test that shows a proportion has decreased below 0.8%, it's going to be a test of proportions, not means. So I'm going to have P here and P here. No matter what, whether it's means, proportions, any type of hypothesis test whatsoever, equals to is always the symbol that I use for my null. For the alternative, I have to read and determine whether they're trying to show a greater than, less than, or not equal to alternative. So they're showing the percent of defectives have decreased below 0.8%. That means what they're trying to prove is that the proportion is less than that amount. If it's decreased below this, it's less than. Now that I have my symbol set up, I need to see what to compare it to. If this had said 80%, when I changed it to a decimal, I moved the decimal point 2 places and get 0.8. So if I was trying to show a decrease below 80%, the correct answer would be P is less than 0.8. That's not what this says. This says below 0.8%. If I want to change that to a decimal, when I move over 2 spots, I get 0.008. So this should be the null of P equals 0.008, and it should be the alternative, P is less than 0.008.